Alright guys, good morning, good afternoon, whatever time it is that we're doing this. I'm recording this during the holidays. It's a rainy, grey day outside, so the lighting perhaps isn't great, but hopefully you can see the board properly. And today we're going to talk about the second part of the chapter, which is the early and the late event times. So here I just have an activity network where all I've done is replace the shape of the nodes. So from last lesson you will remember that each node was a circle, and we wrote in them kind of the step that it was, the order that the events, the activities took place, and I've replaced that circle with a double box. That's it, okay? And each box is going to represent the earliest time that we could start an activity and the latest time that we could delay the start of an activity without affecting the overall duration of the project. So the top box is going to tell me what's the earliest that I could start an activity, and the bottom box is going to tell me what's the latest that I could delay starting an activity without affecting the overall length of the project, because some tasks are not critical, which means that we can sort of delay the start of them a certain amount of time, and that won't have an overall effect on the overall duration of the project. Now, here in this diagram, I've got my activities A, B, C, D, E, F, G, and remember, they all have to converge on the sync node there, and we start at the beginning. The earliest that I'm going to start the first activity is 0, because as soon as we start, that's it, we start counting from 0. So your early start time for your first activity is always going to be 0. That's when we start counting. We're going to complete first the early start time for every activity in what is called the forward pass. So we're going to go from left to right in the diagram, completing the early start time of each activity, and then we will go backwards, hence why it's called a backwards pass, and we will do that to find out the late arrival time, or the latest we could start an activity without delaying the project. Now, quick recap from last lesson. Why have I got a dotted line there? Why is that line dotted? Correct, it is a dummy activity. It doesn't have any time cost, any financial cost. It's just there to tell us what was that dotted line telling us. It's telling me that activity F depends on D and B. So before I start activity F, I must have completed activities D and B. Okay, well, having said that, let's start finding the what does the book call it? It calls it the early event time. So what's the earliest I could start an activity? All right, here we go. Activity A, because it's the first one, the earliest it's going to start is at time 0. And it takes 2 hours or 2 days or 2 minutes or 2 million to complete, so that's why I have a 2 here. Now what this means is that activity C will begin, or the earliest it can begin, the earliest that activity C can begin is 2 hours or 2 days or 2 weeks into the project. Okay? Activity C takes 4 hours to complete, plus the 2 previous hours. It means that the earliest that we could start activity E would be 6 hours into the project. That's the earliest that we could start it. I'm going to stop there. I'm not going to go all the way to F. I need to fill the tree in some sort of logical order, and you will see why. Okay, B takes 7 hours to complete, so starting from 0. B takes 7 hours to complete, which means that the earliest I can start activity G is after 7 hours. Now here comes the bit that you need to be really careful. What's the earliest, think about it, what's the earliest I can start activity F? Well, it's going to be this number here. And you're going to think, well, activity A takes 2 hours, activity D takes 3 hours, so that's going to be a 5 there. But remember, activity F depends on D and B. So both D and B must be completed before I can start activity F. And activity D, to complete activity D, it will only take me 2 plus 3, 5 hours, but I also need B to be completed, and B takes 7 hours. So if those two must be completed before activity F can start, that's going to be a 7. Because activity B takes longer than A and D. So that's why I have a 7 there. So the early event times are always going to be the highest value of the path to get there, if that sort of makes sense. So therefore, having said that, now we can do this bit here. What is the highest number? What's the highest number out of all the arrows pointing into the sync node? Because activity E will take 2 hours plus the 6, that would be an 8. 7 and 1 would be an 8. But activity F can only start after D and B have been completed, and we need our 7 hours plus 4, 11. So 11 hours is the earliest time that we could complete the whole project in. That's if everything runs smoothly, if everything was fine, it would be 11 hours that we could complete the project. And that is how you find the early event time. Now we're going to try to find the late event times. So what's the latest that we could leave the start of an activity until without affecting the overall length of the project? Because that's the crucial bit, okay? So what's the latest I could leave an activity without increasing that number there, okay? So we're going to perform what's called the backwards pass. So we're going to work our way backwards. Your early event time and your late event time for the sync node has to be the same, because we don't want the project to overrun. So if that's the earliest we can run it in, then the latest we can run in is also going to be 11. We don't want to delay the project. That's the idea. Okay. Because activity E only takes 2 hours, 11 minus 2 is going to be 9. I could delay activity E until 9 hours into the project, and that wouldn't affect the overall length, because if I started activity E at 6 hours plus 2 would be 8, I still need to wait for the others to be completed, so E has got a bit of leeway. If I leave, the latest I could leave E is 9 hours, because 9 plus 2 would be 11, and then we'll finish on time. So E, there's a bit of leeway there. Then, if I work my way backwards, 11 minus 4 is, quick math, 7, hopefully. 7. So that's there. And now here, well, let's go back to that. Let's do that one there first. There's two ways to get here. 9 minus 4, which is, I can't do this, I don't know what's going on. 5, thank you. And 7 minus 3, which is 4. So I am going to choose, and 7 minus 3 is 4, number 4 is 4. So I'm going to choose, I'm going to write a 4 there. I could delay activity C, or the start of activity C, up to 4 hours. Same thing with activity D. I could delay its start until hour number 4 into the project. Here, I've got 11 minus 1, which is 10, but 7 minus 0, remember, dummy activities don't have any cost. 7 minus 0 is 7, and I have to choose the lowest out of the two, so that's going to be a 7 there. And now 4 minus 2 is 2, but 7 minus 7 is 0. I have to choose the lowest out of the two, and that sort of makes sense that I have a 0 there, because if I delay that activity A, I will delay the whole project, won't I? It's the starting activity. If I delay the start, then the completion of the project will take longer. So that's how you perform the backwards pass, and that's how you find the late event time for each activity. And now, here is the next thing, the next bit of information. It's the identify the critical path. So, which activities are non-critical and which are the critical activities? The critical activities are very easily identified from the activity network diagram because they have the same early event time and the same late event time. They are the activities that if I delay, the whole project gets delayed. So we can see here that B and F are the critical activities. B and F are my critical activities. If I delay them, the whole project will get delayed. And finally, the last thing to cover in this lesson is something called the total float. Okay, so what's the total amount of time that an activity can be delayed without affecting the whole project? Now, this only applies to non-critical activities. For critical activities, we know by definition that we cannot delay them, because if we do, the whole project gets delayed. So the float for any critical activity is always going to be 0. So back in my example here, let's find out which are the non-critical activities. But looking at it, activity C and E are the non-critical activities. And here we go. So for the formula to find the total float of a non-critical activity is given by a simple formula. Is the late finish time minus the early start time minus the duration of the activity. So let's look at C. The float for C, so the float is going to be, what's the latest that we can finish activity C? Well, it's 9. The latest it could finish would be 9. So it would be 9 minus the earliest we could start activity C is 2, and the duration of activity C is 4. So 9 minus 2 is 7, minus 4 is 3. So 3 is got, activity C is got a float of 3 hours. We could sort of shift it around 3 hours. What about activity E? So the float for activity E will be the latest that we could finish activity E, which is 11, minus the earliest we could start it, which is 6, minus the duration of E, which is 2. 11 minus 6 is 5, minus 2 is another 3. So there you go, there you have it. That is that. The other activity that is actually not critical was G. So for G, the late event time was 11 minus the earliest, which is 7, minus 1, which is another 3, isn't it? Alright, 11 minus 7, 4 minus 1, 3 is another 3. There you go. So it just so happens that each activity that is non-critical has got a float of 3. The critical activities, like F, 11 minus 7 is 4, take away 4 is 0, so they have a float of 0. Oh no, we have another one, don't we? It's, and D as well is not critical. D is not critical. So D, the float for D would have been 7 minus 2 minus 3, 5 minus is 2. Ah, there you go. One with a float of 2. So my critical activities are B, F, that's it. Sorry, that was it. It was B and F, we saw from before. So the non-critical ones are here, and that's the float of each non-critical activity. And if you've been paying attention, you would have realized that A is also not a critical activity. So for A, the float would have been the late finish time for A, which is 4, minus the early start time for A, which is 0, minus the duration, which is 2. So maybe a way to identify the critical activities a bit more clearly would be to say which activities are between boxes with the same early event times and late event times. So these two boxes here have got the same early and late event time, so the activities in between must be critical. That's not the case for G, because we can see that the float for G we calculated was 3. But for F, which is the one between two boxes with the same early and late event times, gives me a float of 0, so F is a critical activity, and B as well, because it is between two boxes with the same early and late event times, and the float of B is 0. So there you have it. And basically that is it. That's all I had for today. So hopefully it makes sense, hopefully it was clear. I will upload the video plus a PowerPoint on these together, and you can have a go, and hopefully we'll solve any questions you may have, or any queries, or any issues. Thank you for watching. Like and subscribe, comment, let me know, and I'll see you soon. Bye.